So before getting into the actual course, let me show you the trailer of this course. Okay, so here we will be seeing a trailer of the movie. Okay, just hold on to your seat for the more action. But before that, let me show you the glimpse of it. Okay, so what all techniques we'll be using in the supervised machine learning process with respect to the stepwise techniques. So step one is data acquisition. In as I told you, data acquisition. So where we'll be using data acquisition is nothing but we will gather raw data from various sources such as databases, APIs, and files. So here we'll be doing data collection, the data integration, and the data loading. So the techniques which are required to do these things, all those techniques we'll be discussing in detail with the theory, practical coding, and we will also look into the libraries. Everything you'll get a 360 degrees of learning in this course. So then we have the data cleaning. So data cleaning is nothing but clean the acquired data by handling missing values, outliers, and inconsistencies, and that's what we'll be doing. Identify the null values, handling null values, then outlier detection. So data imputation techniques, deletion techniques, everything in detail. I told you a 360 degrees view of supervised machine learning process learning. That's what you'll get it out as an output here, just for free of cost. Of course, I require your attention and time. So then we have a step 3, which is ADA, exploratory data analysis. Basically, it conducts exploratory data analysis to understand the data's characteristics, distributions, and potential patterns. To do that, we require a data profiling techniques, summary statistics, data visualization, correlation analysis, and outlier detection. So, of course, most of them are descriptive statistics concepts that we will be dealing with it. And then step 4, feature engineering. As I told you, feature engineering is nothing but converting a raw variable into a feature, converting a raw variable into features, and this is what is called feature engineering. So the feature engineering will be done using univariate selection or feature selection algorithms, dimensionality reduction methods, normalization or standardization, and log transformation. So where are various techniques, each and every technique we will be deep diving into. And data encoding, the most important one, data encoding techniques. So then we will be moving on to the step 5, which is data splitting. So data splitting, split the data into training, validation, and test sets. So here we will divide the data set into various components, and we'll be understanding random sampling, simple random sampling, stratified random sampling. Where do we need to use a simple random sampling? Where I have to use a stratified random sampling? What are the applications? What are the pros? What are the cons of using the respective sampling technique? Okay. So then we will move on to the step 6, which is model selection, or in other way, just to put it in easiest way, it's a model creation or creating an instance. It's simply, let's call it as a model creation. So here we will of course, as I told you before, we'll begin with a base model. For every problem statement, we'll begin with a base model. For me, the base model for the linear regression task is linear regression. For classification task, logistic regression. So you also have a base model. On top of that, you can keep on building it. At least some or other way you can start working on with your project with the base model. So you just instantiate your model. You create your model class object. Once your model class object has been created, now we'll move on to the step 7, model training. So here we have to apply the fit method from the model object and apply the fit the training data into the model. Simple. Then we will move on to the step 8, model testing. Same again, apply the predict method from the model object and use the except test as a feature data to that, so that you'll get the y subpred, the predicted target values from model that has been built and then you will have a x sub test, which are the test values or actual values. So by comparing uh, these two values, y sub pred and x y sub test, y sub pred and y sub test, you can gauge the performance of the model, and that's what is the step 9, which is model evaluation. So model evaluation could be mean absolute error or r square coefficient or mean squared error. So here what happens is it will take the y sub pred, the predicted values from model testing step, and then y sub test, the test values which is kept at 20% or 30% values from the data set. So it will, this following metrics will be applied to the respective data set y sub pred and y sub test, and it will give you the basically error. So how much error it is coming, the error should be minimum. If you get a model with a minimum error, that's what we're gonna choose. So this is what we call it as a model evaluation. So then we will move on to the step 10. This is model optimization. So here we will optimize the hyperparameters. So we will be tuning the hyperparameters such as random CV, random search CV, or systematic one, which is grid search CV, or Bayesian search CV, or Bayesian search, or you can go for the boosting one. So a gradient CV, or you can go for the gradient optimization. Either you can go for the Bayesian optimization or gradient optimization. Just to put it all together, for hyperparameter tuning, you can use either random search CV or grid search CV. Then you can use Bayesian optimization or gradient optimization, where a stochastic gradient descent can be used, or else you can use ensemble techniques to optimize your model, or you can go for the, or else you can use automated hyperparameter tuning tuning libraries such as Optuna, or HyperOpt, or Scikit Optimize, or Scopt. So these are different tools. So analyze model performance, optimize hyperparameters, perform. Of course, these are all, again, you just re-perform the feature selection. Here you come back to this step, you come back to this step. So you have to perform feature selection or dimensionality reduction, or iterate for improvement. So that's where this iteration starts, and repeat it. Just repeat it until you get the good one. Just you repeat it, and that's where the model optimization step is the one which connects back to the feature engineering step. So, and it will repeat it, the process will be repeated until you get the perfect and fantastic and the model which performs absolutely well with the least amount of error. So this is called a supervised machine learning process. Again, I'm telling you won't find anywhere this kind of infographic. This has been made out of my own experience. I have worked on machine learning models and deep learning models for years and years. So I put my complete experience and I made this infographic and animation, which makes supervised machine learning process much easier. And the whole course uh, has been laid out based on this infographic only. So we'll be getting into this course, and we'll start with data acquisition techniques. Then we'll move on to data cleaning, EDA, feature engineering, data splitting, model selection, model training, model testing, model evaluation, and finally model optimization, and we'll repeat it again. So this is the course, and I would love to welcome you to the world of supervised machine learning process.